Hey guys, welcome back. Today we are going to do transformations on shapes in a coordinate plane. So first we're going to do dilations, and we're going to do these using matrices. So for dilations, that means we are either going to expand or shrink a shape. Okay, so a dilation is when something grows larger or gets smaller. So a triangle with vertices 2, 3, 4, -2, and -4, 0, we are going to dilate with a scale factor of 2. So in order to do that, we're going to put the coordinates into a matrix. And I'm sorry about that little break right there. For some reason, this program breaks up some of those brackets, so we'll just have to pretend it's not doing that. So the x coordinates go on top, so that's 2, 4, and -4 across the top. And the corresponding y coordinates, 3, -2, and 0 across the bottom. So that builds us a matrix for the coordinates of triangle ABC. And we're going to dilate with a scale factor of 2, so we are going to do scalar multiplication. So that gives us all of these multiplied by 2, 4, 8, -8, and 6, -4, 0. So the coordinates become 4, 6, 8, -4, and -8, 0. So there's our triangle dilated by a scale factor of 2. So next we're going to dilate a quadrilateral with these vertices by a scale factor of 0.5. So that's 0.5 times, and then we've got -2, -7, 6, -2, 0, 3, -6, -4. So that is -1, 3, 0, -3. Those are our x coordinates. And our y coordinates, -3.5, -1, 1.5, and -2. Okay, so we'll do our best to approximate those decimals. We've got -1, -3.5. About right there. And then 3, -1, 0, 1.5, and -3, -2. So we notice this one actually got smaller, but we're multiplying by a decimal between 0 and 1, so that is going to shrink the shape. So next we're going to do translations with matrices. A translation is a shift. Sometimes people call it a slide. Okay, so we're going to translate a triangle with these 3 vertices, same as the first problem. 3 units right and 5 units up, and to do that we are going to use addition. So we are adding 3, -5 to all of these coordinates. Okay, so we add all of our corresponding elements. 2 plus 3, 4 plus 3, -4 plus 3. And then 3 plus -5, -2 plus -5, and 0 plus -5. So our new coordinates are 5, -2, 7, -7, and -1, -5. Okay, so now we are going to translate our quadrilateral. So it's -2, -7, 6, negative 2, 0, 3, negative 6, negative 4. 2 units left, so left would be negative 2 to all of the x coordinates, and 4 units up, so that's a positive 4 to all of the y coordinates. Negative 2 plus negative 2, 6 plus negative 2, 0 plus negative 2, and negative 6 plus negative 2. And then adding 4 to all of the y coordinates. Negative 7 plus 4, negative 2 plus 4, 3 plus 4, and negative 4 plus 4. So we have negative 4, negative 3, 4, 2, negative 2, 7, and negative 8, 0. Okay, reflections and rotations with matrices. When we do a reflection, that's flipping the figure over a line of symmetry. And for our purposes, we're going to flip either over the x-axis, the y-axis, or the line y equals x. When we do a reflection over the x-axis, we multiply by this matrix. So we multiply our matrix of the coordinates by this matrix. Over the y-axis, by this matrix. And over y equals x, by this matrix. Okay, rotations are similar, but we're going to rotate 90 degrees by multiplying by this, by 180 degrees by multiplying by this, or by 270 degrees by multiplying by this. So our first reflection is the triangle with these 3 sets of coordinates. So here it is put into a matrix. And we are reflecting over y equals x, or over the y-axis. So the y-axis, that's what we're going to multiply by. Negative 1, 0, 0, 1. Okay? So we've got negative 1 times 2 over and down is 0 times 3. Okay, so that gives us negative 2. Okay, then the first row by the second column, negative 1 times 4 and 0 times negative 2. Okay, first row by third column, negative 1 times negative 4 and 0 times 0. And then we go on to the second row by the first column, 0 times 2, 1 times 3. 0 times 4 plus 1 times negative 2. And 0 times negative 4 and 1 times 0. So those are our new coordinates. Negative 2, 3. Negative 4, negative 2. And 4, 0. So there it is reflected over the y-axis. So the y-axis is our line of symmetry. Okay, so now we're going to reflect over the x-axis, and if we go back and take a look at our different matrices, reflection over the x-axis is multiplying by 1, 0, 0, negative 1. Okay, first row by the first column, I get negative 2 plus 0. 6 plus 0. 0 plus 0. and negative 6 plus 0. Okay, so I've multiplied the first row by each column. Now the second row by each column. 0 plus 7. 0 plus 2. 0 minus 3. 0 plus 4. So those are my new coordinates. 0, 7, 6, 2, 0, negative 3. I have a problem with my first coordinate there. I should have had negative 2 plus 0. So that should have been negative 2, 7. Okay, and then I've got negative 6, 4. So there it is reflected over the x-axis. So that x-axis is our line of symmetry. Okay, a rotation. So we're going to rotate about some point, and that point for each of these is going to be about the origin. So the origin will be the center of our rotation. We're using multiplication again. So if we go back to our table, the rotation matrix for a 90-degree rotation is 0, negative 1, 1, 0. So we're going to rotate this matrix 90 degrees by multiplying by 0, negative 1, 1, 0. So first row by the first column is 0, minus 3. First row by the second column is 0, plus 2. And first row by the third column is 0, plus 0. Then the second row by the first column, 2 plus 0. For second row, second column, 4 plus 0. And second row, third column, negative 4 plus 0. So those are our new coordinates. So we've got negative 3. I'm going to erase that origin so it doesn't distract us here. So we've got negative 3, 2, 2, 4, and 0, negative 4. And there it is, rotated 90 degrees about the origin. And in our last problem, we're going to rotate 180 degrees. So we'll go back to our chart here. Rotation of 180 degrees, negative 1, 0, 0, negative 1. So we're going to rotate this 180 degrees. So that matrix again was negative 1, 0, 0, negative 1. Negative 2, negative 7, 6, negative 2, 0, 3, and negative 6, negative 4. Okay, so first row by the first column, we've got 2 plus 0. Then the second column, negative 6 plus 0. 0 plus 0. And 6 plus 0. Then the second row by each column, 0 plus 8 plus 7, 0 plus 2, 0 minus 3, and 0 plus 4. So that's 2, 7, negative 6, 2, 0, negative 3, and 6, 4. And there it is, rotated 180 degrees.